Okay, this is a video about inscribed angles. So here we go. Inscribed angles! Woo! So an inscribed angle is an angle that's inside of a circle. And the way it works is you have two chords. There's a chord and then you have another chord. And it is an angle that is on the circle. This is not to be confused with a central angle, which is from the center of the circle. Then the other side that you have to worry about, if this is the angle, let's call it x, this is the intercepted arc. So there's a relationship with this. If you remember, the central angles are 70 degrees and 70 degrees for the intercepted arc. They're equal to each other, okay? Intercepted arcs and inscribed angles are different. So I'm going to show you that difference really quick. So here's a circle. And I'm going to take some rubber bands. Hopefully I don't break these tacks off of this. But so the idea is if I put a rubber band here and I do this, that represents our central angle. And it looks pretty close to 90 degrees. So here's an inscribed angle. And let's sort of look at the difference of this. And so I'm going to stretch this out all the way to this tack. This looks a lot smaller. In fact, let's say this is 85 degrees. That means this arc is 85 degrees. I'm telling you right now that this is going to be half that size, so like 42.5 degrees. And that's how it works. There's a visible difference in this. In fact, I'm going to take a chance that I'm going to get tacks flicked at me. If I keep stretching it further and further and further, the angle keeps getting smaller and smaller and smaller. So the next lesson after this one, we're going to talk about angles that are on the exterior of the circle. They're even smaller than inscribed angles. Okay? So we've got central angles, which are the same, and we have inscribed angles, which are exactly 1/2 the size. 1/2 of the arc. Okay? That's the main part of the lesson. So now it's just a matter of showing you different scenarios that we've got to deal with. Okay, for this scenario, we've got an intercepted arc. Let's say it is 90 degrees. Okay, so we're not going to talk about central angles now. We're going to talk about inscribed angles. So inscribed angles, like I said, is half the size. So that means if that's 90 degrees, that means this angle is 45 degrees. But this is where it gets a little weird. I can create more than one inscribed angle with that arc. So if I put, ooh, almost flicked it off into the distance. If I do this one, that angle over here is also an inscribed angle for this intercepted arc. That means this angle is also 45 degrees. I can do another one. Now I'm in danger of this really just exploding on me here. So if I do this angle over here, don't laugh at me. This angle here is also 45 degrees. So even though it's pulled over here in this weird location, it doesn't matter. So no matter where I take this, and I'm going to take all these off really quick. The idea is no matter where I go on this circle, no matter where that inscribed angle is located, it's going to always produce a 45-degree angle. So that's one of the main things that we're going to be quizzing you on and testing you on. There's going to be these weird problems with all these lines all over the place. And the secret is they might have the same inscribed angle and the same intercepted arc. Okay, here's a weird situation. So the intercepted arc is going to be this entire piece right here. Now, you might notice something in the picture. I'm not going to give it away. Instead, I'm going to go ahead and do my rubber band across these two tacks, and I'm going to pull it here. Well, what you're supposed to notice is that this is the diameter. And if that's the diameter, this has got to be 180 degrees. And if that's 180 degrees, this is a 90-degree angle. So the way it works is any diameter will produce right triangles. So this is supposed to be 90 degrees over here in this situation. So 90 degrees there, 90 degrees there. Really, anywhere I put that intersection, that intercepted arc, if you have a diameter going across here, that's going to be a 90-degree angle. So it's a special case for inscribed angles. Okay, this is an even crazier example. So imagine I just put 4 random tacks in random spots, I don't really care where they go, on this circle. So if I have these 4 random tacks, and I connect the dots, what shape is that? That's right, it's a four-sided shape. It's a quadrilateral. So we've got this quadrilateral. It's an inscribed quadrilateral. And because it's inscribed, we can actually talk about it in weird ways. So give me a second as I try and figure this out. So we've got an intercepted arc over here. I don't really know what to say. It's twice as big, right? So let's say this is 100 and, let's just say 100 degrees, okay? 100 degrees. That's got to be 50, right? Okay. How big is it for the rest of the circle? If that's 100, and the whole thing's got to add up to, dramatic pause, 260, then if I do another inscribed angle over here, ignore the other rubber band, just look at this one. This is an inscribed angle for this other arc. This angle is 130 degrees. So what do you think you're supposed to notice about the angles on this quadrilateral? That's right. The opposite angles are supplementary. So there might be problems where I give you a quadrilateral in the picture and it might seem like there's not enough information. The fact that these are inscribed in a quadrilateral situation, these have to add up to 180. This is not a parallelogram, this is not a trapezoid, this is just a random quadrilateral. But because it's inscribed in a circle, this works. Okay, the last thing I need to talk about has the same property as an inscribed angle, but it's technically not an inscribed angle. So to illustrate this, what I'm going to do is I'm going to draw the diameter of the circle, and I'm going to draw a tangent to that diameter. Now, if you do this and you remember how tangents work, if this is the radius that goes to this tangent, do you remember that tangents are 90 degrees? And do you remember that if this is 90 degrees, that's great. And if this is the diameter, this is 180 degrees, like this. What do you notice about those two numbers? That's right. This is 1/2 of 90, just like an inscribed angle. So even though it's not an inscribed angle, because the angle's not inside the circle, it actually produces the same property. So we can do this with other kind of situations. It doesn't have to be a diameter. So here's another situation. You have to have a tangent. So let me just draw a tangent for us really quick. Here's our tangent. And so then I'm going to draw a chord off of that intersection. It doesn't really matter where it goes. So let's say I draw the chord here. There is a relationship between this intercepted arc and this angle here. So if this intercepted arc is 95.7 degrees, this angle is 95.7 divided by 2. And we also know that there's a relationship with these two angles. These add up to 180. And there's a relationship with these two arcs. These arcs add up to 360. So there's all kinds of really cool, neat relationships going on in this picture, and you're going to have to be able to realize that. So this is like an inscribed angle, even though it's a tangent with a chord. And that's the end of the basic skills. So now I'm going to do a couple examples really fast, and just to show you some of that kind of things you might see on a quiz or a test. Okay, I've got 8 really fast examples. So really basic. What I want you to do is I want you to try and predict the answer before I give it away. So if I give you this problem, this should be a slam dunk problem. Everybody gets this right. If this is 50 degrees, this is 25 degrees. So my cat was trying to answer it, but honestly, he was wrong because he's a cat. So if I have you have a different inscribed angle, and I tell you this is 30 degrees and this is X, be careful on this one. It's either 15 or it's 60. This is the intercepted arc. This is actually the bigger number. The intercepted arc is 60 degrees on this problem. So now I've got a situation. I've got an angle here, an inscribed angle. I have another inscribed angle over here. So it looks sort of like a butterfly or bat wings or whatever you want to call it, a bow tie. Both of these angles have the same intercepted arc. You could figure out what this intercepted arc is, but I'm not asking you to do that. I'm asking you to look at this angle and look at this angle and make a decision. Because if they both have the same intercepted arc, they're equal to each other. Okay? So if I give you a weird variable problem with some x's and y's and stuff, you can still set those equal to each other, which is really cool. Let me give you another one. Here's a chord. Here's a tangent. I tell you that this is 60 degrees. I want to know how big this arc is over here. This is a multi-part problem, so this is 120, but that's not the answer. I want to know how big this is, so I have to take 360 and subtract 120 to get my answer of 240. That's the answer for that. Here's another one. I give you a diameter. I tell you that this is a tangent, and I want to know how big this angle is. That's right, that's an easy question. You guys should have got 90 degrees for that one. That's not bad because tangents are automatically perpendicular. Well, let me give you another one. If this is a diameter and this is an inscribed angle, how big is that angle? Again, a trick question. That has got to be 90 degrees because this arc, this intercepted arc, is 180. Here's another one. I draw a quadrilateral. It's not a square. I don't know what it is, but I tell you this is 70 and I tell you this is x. X has to be 110 degrees. And lastly, I give you this inscribed angle. I give you a central angle. The central angle is 110 degrees. I want to find the inscribed angle. This has to be 110. This has to be half that size, so this is 55 degrees. So that's the basics. The only way I can make this harder is by putting variables, x's and y's, like 2x and 50 plus 3x and things like that. But you have to sort of know the relationships. So your homework assignment that's related to this lesson are going to have some of those variable problems. Try them out. There's keys on the internet, so you look on Schoology, you can find those things. And you can ask questions before school because I am in the building, or you can hit the tutoring center. Thank you.